from the Suez Canal.
Suez Canal.
Suez Canal.
Suez Canal. That massive container ship still stuck, blocking traffic in both directions, causing a giant traffic jam for ships that move much of the world's goods.
Hello everyone, today our group will be presenting the article, The Cause of Maritime Supply Chain Disruption, the Case of the Suez Canal. Before I start my presenting, let me introduce our groupmate, which is Chai Yu Chen, Sheng Jie, Pan Jiayi, and me, Teo Hui Sing, and Yang Jianling. Next, I will start by the introductions and relevance of a selected article. We selected this article because it examines one of the major maritime disruptions in recent years. In March 2021, the Ever Given blocked the Suez Canal for 6 days. As a strategic maritime point and an important global trade route, the canal carried around 12% of global trade. The blockage delayed hundreds of vessels and disrupted supply chains worldwide. This case highlights the importance of risk management and supply chain resilience in international transport management. In these presentations, we will summarize the article, explain its methodology and key findings, evaluate the author's arguments, and discuss recommendations for improving the resilience of global maritime supply chain. Now, I will briefly summarize the selected article. The research focuses on the Ever Given incidents, where the ships blocked the Suez Canal for 6 days in March 2021. This disruption delayed more than 400 vessels and significantly affected global supply chains. To investigate the impact, the researchers use a quantitative case study approach. They collect international shipping and trade data and apply economic modeling to estimate both the direct and indirect costs of the blockage. The study found that the disruptions lead to higher shipping costs, port congestions, inventory shortage, and product delay. As a result, logistic costs increased, delivery were delayed, and global trades were negatively affected. For the next, based on this finding, the author concluded that the Ever Given incident exposed the vulnerability of global supply chains, especially those that rely heavily on strategic maritime routes such as the Suez Canal. The study also showed that the disruptions at critical points can quickly spread throughout the global logistics network, affecting not only shipping companies but also port, manufacturer, retailer, and consumer. In conclusion, even a short-term disruption can create significant economic and operational impact worldwide. Therefore, strengthening supply chain resilience and improving risk management are essential to reduce the impact of future maritime disruption. Thank you. Next, I'll pass to next presenter.
Now I will present the main argument that we are agreed with. The first point we are agreed with is the strategy choke point increase the supply chain vulnerability. The paper highlights that the importance of the Suez Canal is the key maritime connecting Asia, Europe, and North America. The vulnerabilities was clearly shown during the Ever Given incident, where a 6-day blockage delayed the 422 vessels and disrupted the global trade activities. We agree with this argument because the global supply chain is heavily dependent on the maritime transportation. According to the ITM Transport Outlook, around 86.6% of the global freight volume is transported by the sea. Therefore, when the major choke point is disrupted, the impact can quickly across different regions supply chain network. This also supported by the Chris Porter and the Pace, who explained that the modern supply chain is heavily interconnected. The disruption one critical point can create the cascading effect throughout the entire network. The recent Red Sea crisis further showed this. The disruption of the metal trade forced the more than the 80% Asia to Europe container vessels to reroute around the Cape of Good Hope, leading the longer transportation time and the higher cost. Now let's move to the second point is the inventory carrying costs are the largest hidden cost by the maritime disruption. One important finding in the paper is the inventory carrying cost around 86% of the max total loss, while the ship operation cost only around 9%. This shows that the impact of the supply chain disruption goes beyond the direct transportation cost. We agree with this finding because the inventory acts as the bridge between the production and the customer demand. When the disruption extends to the transportation lead time, in the transit longer and more capital is tied up in the inventory. The paper also highlights that the effect of the cargo value was approximately $26.5 billion US dollar. Therefore, even the few days of delay can significant financial impact due to the higher inventory holding and the capital cost. Let's move to the last agreement point. The third point is we agree that the maritime disruption also create the environment consequences. The paper estimates that the effects of the mass freight generate an additional 44,000 of the CO2 emissions. Most of the emissions came from the vessels that were forced to reroute around the Cape of the Good Hope because a longer sailing distance and increased the fuel consumption. We agree with these points because the disruption is not only delay cargo movement, they also change the normal shipment operations. Longer routes and the effort to cover the schedule require the more fuels, which lead to higher greenhouse gas emissions. This further support by the UAE, who found that the increasing vessel speed to recover the schedule can significantly increase carbon emissions. Similarly, the UNCTAD estimate the prolonged Suez Canal disruption could increase shipment emissions by up to 17%. Therefore, we are agreed this orders the maritime disruption should be considered not only the economic issue but also the environment sustainability issue. With that, in next part we will discuss the argument that we are disagree in this paper. Thank you.
Now I will present the three areas where we disagree with the study analysis of the Suez Canal disruption. First, the study has limited generalizability because it only analyzed Maersk Line East-West shipping network involving 69 vessels. Although Maersk is one of the major shipping companies, its operation cannot fully represent the entire container shipping industry. Other companies such as MSC, CMA, CGM, and COSCO may use different vessel size, shipping routes, schedules, and operational strategies. Therefore, the result based on Maersk alone may not apply equally to other shipping companies. Our critique is that future research should include the data from several shipping companies. This would provide a more complete industry perspective and improve the reliability and generalizability of the findings. Second, the study may have oversimplified the inventory carrying cost. The study concludes that inventory carrying costs represent around 86% of the total disruption cost. However, this calculation assumes a fixed inventory holding rate and similar cargo value across different shipments. In reality, cargo types are very different. For example, electronics normally have a higher value than basic raw materials, while food products may be more time sensitive because they can expire. Machinery may also have different storage and financing costs. As a result, using one inventory cost assumption for all cargo may overestimate or underestimate the actual economic impact. A more accurate analysis should calculate the inventory cost according to the value, type, and time sensitivity of each cargo category. Finally, the study provides an incomplete environmental assessment. It reports additional emission of carbon dioxide, nitrogen oxide, sulfur oxide, and particulate matter. However, the estimated environmental cost of $4.46 million is calculated only from carbon dioxide emission. The health and environmental effect of nitrogen oxide, sulfur dioxide, and particulate matter are not converted into monetary values. These pollutants may contribute to air pollution, environmental damage, and public health problems. Therefore, the study may underestimate the total environmental cost of the disruption. Our main critique is that shipping pollution involves more than carbon dioxide, so future assessments should include the financial, environmental, and health impacts of all major pollutants. In conclusion, the study is useful, but its finding could be improved by using wider industry data, more detailed cargo cost calculation, and a more complete environmental assessment. That's all from me. Thank you.
So thank you. I will now move on to our recommendation. Based on the finding, we developed three main recommendations. Our first recommendation is to strengthen emergency response and canal redundancy. During the ever-given incidents, the equipment available at the canal was not enough to free the vessel, so external specialists and more powerful tugboats were needed. Therefore, we suggest three actions. First, heavy salvage equipment such as tugboat, dragger, and floating cranes should be positioned near critical section. Second, the canal authority, shipping company, and salvage firms should regularly conduct joint emergency drills. Third, the canal should continue selective widening and duplication. The latest development includes a 10-kilometer duplicate section, a 40-meter widening, and additional capacity of around 6 to 8 vessels per day. Overall, this action can shorten recovery time, reduce vessel quits, and minimize economic losses. So for second recommendation is to use data-driven and low-carbon rerouting strategy. Rerouting may help ship avoid waiting, but the longer route can also increase fuel consumption and emissions. For example, only 12 rerouted Mars vessels produce 37,101 tons of additional carbon dioxide, which represent more than 4/5 of the additional emissions. Therefore, shipping companies should use real-time information such as vessel position, queue length, weather, and cargo urgency to decide whether to wait, slow down, or reroute. The decision should consider time, cost, safety, and emissions. Just-in-time arrival can also help. Previous trials shows an average fuel and carbon dioxide saving of 40.16%. On the other hand, large-scale rerouting can also increase emission by 48.6%. So the key point is the vessels should only reroute when the total impact is lower. So for the third recommendation is targeted supply chain resilience. Around 26.48 billion US dollar of goods were trapped on the affected vessels, while inventory carrying costs reached around $76.29 million, or nearly 86% of the estimated disruption loss. Instead of simply increasing inventory of every product, companies should take a more targeted approach. First, critical and time-sensitive cargo should receive priority. Second, additional safety stock should only keep for important products that are highly affected by delays. Third, companies should diversify their suppliers, ports, and transportation options, including rail and air transportation as backup alternative. In the future, digital early warning system can also help companies react earlier to the possible disruption. The main objective is to improve supply chain resilience without creating existing excessive inventory and unnecessary emissions. That's all from me. Thank you.
Finally, I will conclude our presentation by discussing the future research opportunities and the overall conclusion of this study. Although this study provides valuable insights into the impacts of the ever-given incident, there are still several research gaps that future studies can address. First, the study has limited focus on digital technologies. It mainly analyzes the impacts after the disruption occurred, but does not explore how technologies can help prevent or better manage similar incidents. Therefore, future research could investigate how AI, blockchain, and IoT and the digital twins can improve disruption prediction, real-time monitoring, and response. Second, the study only examines one rerouting option, which is the Cape of Good Hope. Future research could compare different alternative shipping routes and resilience strategies to determine the most effective approach for maintaining supply chain continuity during major maritime disruptions. Finally, the study focuses on short-term impacts of a single disruption event. Future research could examine how recurring disruptions, such as the Red Sea crisis and the Panama Canal drought, affect global trade and supply chain resilience over the long term. This would provide a broader understanding of how repeated disruption influence international transport system. Moving on to the conclusion, the ever-given incident highlighted the vulnerability of global maritime supply chains and showed that even a short-term disruption at a major maritime choke point can create significant economic, operational, and environmental impacts. The findings also suggest that building a more resilient maritime transport system requires stronger emergency response capability, greater adoption of digital technologies, and diversification of shipping routes to reduce dependence on a single choke point. Overall, this study provides valuable insights into the importance of resilience in international transport. As global supply chains become increasingly interconnected, strengthening preparedness and adopting more sustainable transport strategies will be essential to minimize the impact of future disruptions. Thank you.